Hey guys, Mr. Milton here. Today we're going to talk about multiplying special cases. At the end of this video, you should be able to multiply binomials with special cases, and you should be able to identify common occurrences with each special case. So, we are going to use what we know about exponents in order to multiply x plus 3 squared. Okay, so x plus 3 squared, we're squaring something, that means repeated multiplication. So x plus 3 times x plus 3. In our last lesson we looked at two ways to do this, whether it was FOIL or the box method. We'll do the box method here. Again, I don't really have a preference over which method you use, but I do want you to make sure that you're multiplying all the terms together. Okay, so x times x, x squared. 3 times x, 3x. 3 times x, 3x. 3 times 3, 9. Okay, add our like terms together, and we get x squared plus 6x's plus 9. Okay, so when we say square, we're squaring a binomial. That just means we're multiplying the binomial by itself. Alright, we can see that again in this next example. X minus 5 squared, x minus 5 times x minus 5. Okay, I'm going to use FOIL here. Firsts, x squared, outsides, minus 5x.
Josh Salway, if you're in the building, please call the main office at 2202. Josh Salway, if you're still in the building, please call the main office at 2202. Thank you.
Moving on to the second term in our first parentheses, negative 5x. And negative 5 times negative 5 is positive 25. So we add our like terms together. We have x squared minus 10x plus 25. Okay. Do that same thing here. 3x plus 4, 3x plus 4. Got 9x squared plus 12x plus 12x plus 16. Okay, add our like terms together. It's 24x, so 9x squared plus 24x plus 16. Okay, final one, give you another example of the box method. Okay, so 6x minus 1, 6x minus 1 is 36x squared minus 6x minus 6x plus 1. Add our like terms together, so we have 36x squared minus 12x plus 1. Okay, remember to keep your multiplication and addition rules straight in your mind. When you add, you do not change the exponents. When you multiply, you do. Okay? Again, my rule of thumb is if it has to be the same, it has to stay the same. Okay, so in each of these problems, the binomial is being squared. When you have the situation, certain things always occur. The first and last terms of the answer is both positive and a perfect square. So those are the numbers that we can multiply something by to get to. So 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those are the numbers that you should remember. Up to 15 will make it very helpful for you in the near future. Okay. Middle term has to have the same sign as the original problem. So notice that this was minus 5, our middle term was minus. Plus 4, middle term was positive. Negative, negative. Okay, so that stays the same. And then the outside and inside terms are the same when you use foiling. So basically, O and I are going to be the same. You know, so we have 12x and 12x, negative 5x and negative 5x, negative 6x, negative 6x when we're using the box method, 3x and 3x using the box method. Okay, so those terms are always the same. So because of this, we have a shortcut that we can use if we have square terms. Now again, we did all this without a shortcut. We didn't need the shortcut in order to get there. If you have trouble with the shortcut, forget it, skip it. Okay, but if you feel like you can handle it, then let's look at it. Here's the shortcut. You multiply the two terms of the binomial together. So in this example, we have 3n and 5. And so we'd multiply 3n times 5, which gives us 15n. And then we multiply that answer by 2, since the outer terms and the inner terms are the same. You have two of them. So 15n times 2 gives us 30n. So now 30n is the middle term of your answer. Okay, so for this problem, just looking at it really quick, I could say pretty quickly that 3n plus 5 squared should give us 9n squared plus 30n plus 25. Okay, and so the shortcut allows me to look at this and get the answer without having to do too much. Again, because I know that 3n is going to be a perfect square, 9n squared, 5 is going to be a perfect square, 25, 30n. Okay. Try the shortcut on the last problem. Okay, you paused it really quickly. I'm about to write the answer, so pause it and see if you can figure the shortcut out. 4x squared minus 28x plus 49. Okay, you can double check me using either box method or FOIL method if you don't believe it. And it comes to the same answer. Okay, and so that's where that shortcut's helpful. Cuts down on the time a lot if you can recognize that and do it. Alright, on the back side, try these out. Okay, x plus 4, x minus 4, so we have x squared minus 4x plus 4x minus 16. Okay, and so we get x squared minus 16. 9x squared plus 24x minus 24x minus 64. 9x squared minus 64. Do this last one in a box. 4x1, 4x minus 1, 16x squared, 4x minus 4x minus 1. And that gives us 16x squared minus 1. Okay, so FOIL method, box method, multiplying binomials. So in each of these problems, the two binomials are the same except for the sign. When you have this situation, certain things happen. The middle term disappears, cancels out, disappears, kind of sounds like magic. And this is because the outer terms and inner terms are the same except for the sign. Notice we had negative 4x and positive 4x, positive 24x and negative 24x. Okay? The last term is negative, while the first term is positive. So let's try using the shortcut here. Okay, the first term is going to be squared. 5x squared gives us 25x squared. The last term, negative 2, positive 2, negative 4. Okay, because we recognize, hey, these are the same except for the sign between them, we can use that shortcut and save ourselves a little time. Okay, so let's try that down here. Number 1, 8x plus 8 squared. Okay, hey, we're squaring something. We can use that shortcut. X squared, 8 times x equals 8x. And we multiply that by 2. So 16x, that's our middle term. And then this last one should be 8 squared, which is 64. Number 2. Hey, these are the same except for the signs in the middle. So my first term is the first term squared. My last term is the last term squared with a negative sign. Because these are positive and negative, the middle terms will cancel each other out. Number 3. Hey, everything, wait, kind of tricky because you look at this and say, hey, everything's the same except for the sign, but that's not the case. Remember, that doesn't mean we can't do it, that just means we can't use the shortcut. So now, we'll do it using the box method. Okay, so 2x minus 5, 5x plus 2 gives us 10x squared minus 25x plus 4x minus 10. Add our like terms together, we have 10x squared minus 21x minus 10. And then in our final one we have 4x minus 3 squared. Take some time, try this problem out. You can use the shortcut, but if you don't feel comfortable with the shortcut in this problem, use the box or FOIL methods. Okay, try this out, bring it to class. See ya.